let's say that you want to find the velocity of an object dealing with a single instant of time. So you're not given a time interval, but you want to find the velocity with just one time. So let's look at this question here. Suppose a ball is dropped from the upper observation deck of the CN Tower in Toronto, 450 meters above ground. Find the velocity of the ball after 5 seconds. So the first thing you want to do is consider this formula here. Average velocity equals change in position over time elapsed. The tricky part of this, the part that you need to learn, is that when you're calculating time elapsed and when you're calculating the change in the position, you need to come up with the numbers via what's given to you in this time over here, and then like assume that it's a time difference. So in this case, this section of the question is not given. This is the only thing that's being asked. So you might see that in this question, it says that you should use the time interval from t equals 5 to t equals 5.1. Well, if we're going to use 5.1 and the question isn't giving us 5.1, then why should I use 5.1? Whenever you're calculating a time interval, always just add 0.1 to the time so that you can calculate the change in the position over the time elapsed. So what we're going to do here is we're going to fill it in with 5.1 minus 5.0 over the change in time, which would be 5.1 minus 5.0 equals 0.1, or the time elapsed. Because it's asking us, again, to find it after 5 seconds, so it's not asking us to find the time at 5 seconds. It's asking us to find it after, and we just have to assume it's a 0.1 because it's a close estimation. And so when you plug it into this formula over here, you should get 49.49 meters per second. And then below here is a table showing why we use these type of time intervals. As you see, the closer you get to 5, and we started with 5.1, right, over here. But the closer you get to 5, if you did like 5.001 minus 5, if you took this difference, you would get really close to this value, this specific value over here, 49.0049. And so when you look over here, it says it appears that we shorten the time period. The average velocity is becoming closer to 49. Because look, as our time interval gets shorter and shorter, which is the time interval that we've created, it gets closer to 49 over here. And the reason why we don't just enter in 5 is because this is calculus. We need to take the average to find the position properly. So now that we know it's 49, our answer for instantaneous velocity is 49, and then our answer up here is what we calculated using the base